Okay, so today we're going to further our discussion a little bit. We're going to be talking about real numbers. Okay? Now, your second objective for the day, today I will demonstrate my mathematical ability to classify numbers as either rational or irrational numbers through class discussion. All right, let's go ahead and jump right into the lesson. So here's my question. Well, what are real numbers? You may be asking yourself, Mr. Mindy, I thought all numbers are real numbers because they're all numbers, so they all have to be real. There's no imaginary numbers. Well, for right now, all I want you to worry about is real numbers. There's not fake numbers, okay? For right now, all we're talking about is just real numbers. And what do those entail? Well, let's look. I have real numbers, right? Okay. Well, so far we've been talking about rational numbers, correct? Remember when our discussion about rational numbers, we said that rational numbers are fractions. Any number that can be made into a fraction would be considered a rational number. Well, fractions then can be made into two different things because I can go two different routes. I can go to the decimal route, right? And then decimals can be broken into two types of decimals that we can have. We can have either terminating or I can have repeating decimals. Okay? Either terminating or repeating decimals. Then, from there, we go back into the fraction. I go to integers. Where are integers? What are those? And then the whole numbers. Okay? Now, so these all are rational numbers. So rational numbers entails a lot of information, a lot of different types of numbers. Now, the opposite of rational would be irrational numbers. So if I look at irrational numbers, or this whole number system for a little bit, okay, a fraction, like 3/4, right? Okay, decimals, well I can have a terminating decimal like 0.3, okay, I can have a repeating decimal like 0.6 repeating, right? Okay, now, if I don't have either one of those, if I have a decimal that just goes on for infinity, 4, 6, 2, 1, 9, 6, da, 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 da. It's going to go on and on forever. It is a irrational number. Okay, remember what integers are? Integers are simply our positive and negative numbers. So -2, -1, 3, 6, okay? Now, our whole numbers are simply 0, 1, 2, 3, 4. They're only positive, okay? 0 is included, so from 0 and on to infinity on the positive side of the number line. Those are the whole numbers. Okay, well, in your last lesson, you talked about some radicals, okay? Say radical 25. Okay? Well, radical 25 or square root of 25 is 5, right? Well, 5 is both an integer and a whole number. So therefore, a perfect square is going to be a rational number. Okay? So all those perfect squares that you have in your notes from the last lesson are going to be rational numbers. If I give you a number, say, square root of 24, okay, that is not a perfect square, and so therefore, that is irrational, because I'm not going to be able to make that into a whole number. I'm not going to be able to make it into an integer or a decimal or a fraction. So if I can't do any of these things here, it's going to be considered irrational. Okay, remember the prefix ir is not. Okay, so it's not rational, not of the right mind. Rational makes sense, irrational does not make sense. These numbers, they have no point to them. Okay, they're still a number. There's still a number on the number line. It's just they make no sense. So they are irrational numbers. All right, let's go ahead and see how we can use this information now to help classify some numbers. Okay, so now I'm going to classify some numbers. I want to either classify these as rational or irrational numbers. Okay? Well, 5/8, that's easy. That's a fraction. If I go back and look at that tree diagram that we made, okay, fractions are rational numbers. Those are numbers that make sense. Okay, square root of 36. Square root of 36 is 6. That's also an integer, and that's also a whole number. So therefore, that is also a rational number. Okay? I have 0.16 repeating with a 6 repeating. Well, isn't that a repeating decimal? And aren't repeating decimals also listed as rational numbers? Okay. 35/100. Well, what kind of decimal is that? That's a decimal that terminates. Well, isn't a terminating decimal also a rational number? Okay, so that's also going to be a rational number. Now, square root of 42. Is that a perfect square? Look at your sheet. Okay, if it's not a perfect square, which it's not, then it's going to be irrational. Okay? It's not rational. It does not make sense. -5. -5 is an integer. Integers are rational numbers. Okay? 85. 85 is both an integer and a whole number. And guess what? It is also a rational number. Square root of 10. Square root of 10 is not a perfect square, so looky there. It is also not rational. Okay, it's not of the right mind. So in this situation, okay, a lot of the numbers look like they're going to be rational numbers, but I'm throwing some in there that are not rational. You need to understand what rational numbers are and what they aren't. All right? If you have any questions, make sure you bring them to class.